Hello everyone. In this video, we will learn how to find a missing number in a consecutive natural number sequence starting from 1 using ARM7 Assembly Language on LPC 2148. We are given a sequence of numbers from 1 to n, but one number is missing. Here, the number 4 is missing. Our goal is to find this missing number using assembly language. First, let's understand how can that be done. We use a basic mathematical formula, that is, sum of first n natural numbers is given by n into n plus 1 by 2. Here n refers to the total number of elements in the sequence. So, expected sum is sum from 1 to n as given by this particular formula, but actual sum is sum of array elements that is provided to us. Now, missing number is nothing but expected sum minus actual sum. Now, let's implement this logic in our code. At first, let me check if there is any error in this code. No error, so we'll go ahead with debugging. First of all, area here is nothing but an assembler directive which defines a section of memory to store this information. Missing num is nothing but the name given to that section of memory. Code indicates this information contains instructions. Read only because we don't want any modification to be happening to this particular code during runtime. Entry indicates where exactly execution starts. The very first label after entry is the location where the execution actually starts. Start, sum loop, expected sum, stop, all these are nothing but labels. End is an assembler directive which indicates the end of source file. Array is again a label, but you can see DCD here which indicates define constant double word. DCD indicates that all numbers here, that is each number of this particular array, occupies 32 bits or 4 bytes. The very first instruction is a pseudo instruction which will load the address of this particular label array and place it into the register R0. Let's see that happening. Okay, so 3C is the address associated with this label. So if I access that particular memory location by opening the memory window, I can see my actual array elements, that is these elements in this particular memory location. Next, I am initializing my registers, R1 as 7, R2 as 0 and R3 as 8. R1 indicates the total number of elements which are actually present in this array. Total 7 elements are present. Next, we have R2 which stores the sum of this particular array elements. Next, we have register R3 which is stored with the value 8. It represents the value of n. Next, we enter this particular label, okay, wherein the very first instruction checks if R1 is already 0. R1 will become 0 after we finish adding all the elements of this particular array, but currently that is not the case. So this particular comparison will set Z as 0 itself. Okay, once R1 actually becomes 0, Z will become 1, because of which this branch condition will be true. But in the current case, because Z is 0, this condition EQ is false and hence this particular branch will be ignored and we move to our actual load instruction which will load the value pointed by R0. R0 has the address 3C, so the very first content, that is the value 1, is loaded into register R4. After that, R0 is incremented by 4. Let's see that happening. Yes, so now we have our desired element in register R4. We add it with the content stored in R2. R2 is initially 0, so the result of this addition is stored in R2, which will be the same value. Okay, and then we subtract R1 by 1 to indicate that we have already added one element of this particular array. Okay, next, because of this unconditional branch, we branch back to this particular loop. Let's see that happening. Yes, and we again check if R1 is already 0, because that is not the case. This branch will not occur and this loop continues. As you can expect, at the end of every loop, one element of this particular array gets added up. You can see that now R1 is actually 0. So when we branch back to this loop and this comparison is done, Z is set as 1. That is, 0 flag is set as 1 to indicate that R1 is now 0. And we see this particular jump happening. The reason is branch if equal will check if Z flag is 1, because currently Z is 1. Jump will happen to this particular label, which is nothing but expected sum. Now let's see what's happening here. Here we actually calculate n into n plus 1 by 2. We have the value of n in R3, and in the very first step we are calculating n plus 1. So it is R3 plus 1. After that we multiply n and n plus 1, and the result obtained is divided by 2 using the logical shift right operation. One thing you should know here is, for every right shift of any given data, that particular data gets divided by 2. Same thing happens here, and the result is stored in register R6. Okay. Now, since we already know what should be the expected sum, and we have already calculated the sum of this particular array in the previous loop, only thing that is left to compute is the missing number. You have to directly subtract R6 and R2, that is expected sum and actual sum. The result you obtain is the missing number. Let's see that happening. Okay, so R7 is stored with the value 4, which is our actual missing number. Once this step is done, you jump to an infinite loop, that is stop branch to stop. So that's all about this code.